Hey everybody, it's Mr. N here, and we are going to do this lesson on graphing with calculators. So open up take out your graphing calculators, I should say. Mine's a little different here because I'm using the one on the iPad. All right, so what I want to do is I want to show you guys how to graph something on your TI-84. Again, this one is very similar to it on this app, but I'm going to show you how you guys can find all the stuff that we've been doing, such as the critical points, the intervals of increasing, decreasing, the intervals of concavity. Your calculator can find maximums and minimums, but they're going to mainly ask you for critical point. And because of that, we're going to be able to ask you where intervals of increasing, decreasing, concavity, those types of questions instead of maximums, minimums, because it will be able to find them. But yes, they can ask you that as well. So let's take a look at this. Right here on this example, I'm going to do this one right here. I will do that when we actually do it down here. But for now, let's start with number 1, and then I'll come back to this, okay? The one thing I want you to be aware of is these features. When you input y1 vars and y vars, this function is going to be important to us, and I'll show you on your calculator where that is because it's very similar to the one I have here, okay? So let's start off with this first example. It says, use your calculator to sketch this graph and then find the inflection points, any maximum and minimums. I'm going to add into this, I want you to find the intervals of concavity, and I want you to find where it's increasing and decreasing and the critical points and all that stuff. Okay, so the first thing we want to do is we want to enter this into our calculators. So let's go ahead and enter this equation in, and this is going to be under y1. Okay, because you're going to be using y2 and y3 to do other things. So for y2, so for y1, oops, let's use this pen. y1, I'm going to put in this equation. y2, I'm going to put the derivative of y1, which is our function, and then y3, I'm going to put the derivative of y2, right, which would be the second derivative. So for the first one here, let's go ahead and continue on, and we're going to put x squared plus 7x plus 3 all divided by, and I noticed I put the top in parentheses because your calculator does follow the order of operations, and all divided by x squared. And I will go ahead and graph this and show you guys that this is the graph, and on mine I can change the window just like this, right? Yours, you're going to need a little bit more help with changing the window, but on mine I could just pinch and squeeze. On yours you'll have to hit the button that says window and adjust the window. So I've changed my window here to where I can kind of see this and see what's going on with this function. Okay, and I will extend this out here as I need to make it a little bit better for you guys to see, and as we go on with the problem. So I could do something like that and then show it to you guys. And again, I can pinch and zoom and change my scale. For you guys, you're going to have to hit that button that says window and adjust your scale manually. All right, so let's move this back to over here. Okay, so now let's see, how do we find, if I take y1 and I put in this equation, okay, for y2, I want to use the derivative. So here's what I do to do y2. So let's go back here, and we're going to go y equals, and we're going to, under y2, I need the thing that says derivative. Your calculator will do derivatives. If you hit the button that says math, and on your calculators it's on the left side, and I've hit the button that says math, your menu structure is very similar. You're going to scroll down to the one that says n derivative, okay, and that's what I'm going to choose. Now if you have the newer software on your graphing calculators, it'll look like this. If you have the older software, I'll address that in a second. So what I want to do is I want to put the derivative of y1. So I want the derivative with respect to x, so I put the x in there, and then I want to put my y1 equation. So I can't, this won't go there, but I'm looking up over here just so you know where I'm looking, and I'm going to put y1 equation. So I'm going to hit the button that says vars, and it's right over here, and it says vars, and I want to go to y vars. So up at the top you'll have a menu, or it'll give you a menu structure. I want to hit y vars, and I'm going to choose y1. And what it did is it put my y1 equation in so I don't have to retype that equation. So it's really important that you make sure your first y1 equation, you don't make any mistakes putting it in. This helps you so that you don't have to keep entering in this whole equation and say n derivative and have to put the whole thing in. You could just say n derivative of y1. So it's going to take that y1 equation with the derivative, and I'm going to put this with respect to x. So the derivative with respect to x, and I want it at each x point. That's what it means when I say x equals x. And if you hit graph, your calculators may take a little bit longer to graph this than mine, okay? But here's what the graph looks like. Let me change my window just a little bit so you could see. The green is the original. And in fact, I'm going to move this out a little bit. Whoops, I have to undo that. I'm going to move this out a little bit so you can see. The green is the original. And now this purple one is the derivative graph. So that's what the derivative graph would look like. Okay? Okay, if you have the older software, you didn't get that integral when you hit this y equals, you didn't get this d over dx, I should say, this menu format. So what you got in the old software was just a y equals 2, and then when you hit n derivative, it just gave you n derivative like this, like I'm showing you right here. Okay, so what you needed to do is, if you do have the old software, what you have to do is use this n derivative feature. It's going to say n derivative, and then here's what you're going to enter. Let me erase this and put this in correctly. You're going to enter in y1, comma, x, comma, x. How do you get the y1? The same exact process. Okay, to get the same exact process, you're going to hit math, and then you'll hit vars. Let's redo that. Let's recap that. You'll hit the button that says vars. Okay, vars. Right here, just like that. Then you're going to hit and choose the one that says y vars, and then you will choose the function that you want. Okay, so you'll have to choose y1 in this case. All right, so that's how you do it if you do not have the new software, if you have the older software. So now I want to go back to the graph, okay, and I want to show you something. The original right here was the green one, right? And I'll find a 0 right there, and I will hit a minimum value right there. On this, my calculator, it is able to find the minimums just by clicking and dragging. Okay, so that's how I was able to do that. So on yours though, like for instance, see, as I can kind of move it along here with my finger, and same here and over here as well. But now I found a minimum right here. Okay, that is my minimum, and we know this, right? My calculator found it for me, but I'm going to show you how to do it in a different manner. So we're going to say we have a minimum, and we know this at this point, negative 0.8571, comma, negative 3.0833. We know we have a minimum value there. But let's go ahead and find the intervals where it's increasing and decreasing. In other words, where my slopes are positive and where my slopes are negative. And I'm going to use the first derivative to do this. So let me expand this again, and I'll expand it out to just about here so I could do a little bit of both. Okay, so I'm finding this, right? That's a critical point where the derivative is equal to 0. Now, on your calculators, you're going to have to go second, calculate, and then hit the button that says 0. On this one, it doesn't do it that way. But on yours, you're going to be going second and then calculate. You'll have that menu up at the top in the very first row. So here is an image of your calculator real quick just to show you guys. So what I meant by that was, let's enlarge this. You're going to hit second, and then you're going to hit calculate, and that's how you're going to be able to get to that menu, and you're going to go left bound, right bound to find the zeros, just like you did in your previous courses. So when we find the zeros, let's go back over here, let's hit the graph button, and we are looking at this pink graph in my situation, the way I have this laid out. So let's take a look at that. This is your derivative graph. So you come down to here, and that point is, you found that 0. So that point is negative 0.8571. So if we were to do this for the first derivative, so f prime of x, we would get critical points when x is 0 or undefined, right? And so this is our first critical point, negative 0.8571. And taking a look at our graph, let's slide this over so we can look at it. I see an asymptote here at x equals 0, right? So we have another critical point at x equals 0. So this right here is my asymptote, right? So that's why at x equals 0, it's undefined. So I have to examine that point regardless. Then on the other side of the graph, I'm looking at this. It doesn't cross the axes here. If I trace it up, it gets really, really close, but it won't cross it. So you could see that right there, it's getting really, really, really close if you look at the values to 0, but it won't get to that 0 point. Okay, because that's what this first derivative graph looks like. All right, let's slide this back over. So I do have two critical points that I do need to examine. And when I examine those, I'll put those on a number line. And here is 0, and this is negative 0.8571. And I take a look at the slopes. The slopes are all positive on this side, right? I'm above the axes. Let's slide this over again. Let's see if we can get this graph to behave. Okay, so over here, I'm below the axes, so these are negative. Here's a 0, and then I'm above the axes. So f prime of x is what I'm looking at. I'm below the axes. There's a 0, then I'm above the axes. Over here, when I jump to the other side, I'm below the axes again, and we have negatives. So looking at this, you know you have negative slope to positive. So we know we have a relative minimum here at x equals negative 0.857. And then I go from a positive slope to a positive. So it looks like, it appears that I have a relative maximum at x equals 0. However, if you look at the original function at x equals 0, you have an asymptote. So since you have an asymptote there, this trumps it. So we don't have a relative maximum there. So we only have a relative minimum at this point. Let's take a look at intervals of increasing and decreasing. So we are increasing when that slope is positive, so from negative 0.8571 to 0. And we are decreasing from negative infinity to negative 0.8571, union 0 to infinity. Okay, so now let's take a look at intervals of concavity and inflection points. So how do we do inflection points? We need the second derivative. So how are we going to do that? Well, we're going to use our calculator, and we're going to do the same exact process as before. So let me slide this over. I'm going to go to y equals y2, or y3 now. Okay, so when you do this on your calculators, it's going to be a lot slower than this calculator that I have, because this one is obviously using the iPad, which is a much faster processor. So what I want to do is I want to take the derivative of the second equation, right? I took the derivative of y1, that gave me f prime. If I take the derivative of y2, then that will give me f double prime. So same process. We're going to go math. We're going to choose n derivative with respect to x. And now I want to put in y2 right there. So vars, y vars, and I will choose the y2 equation. And then I want this with respect to x, obviously, at every x value. So I hit, now this one's going to be a different color. I hit graph, and I've got that blue one. Now, I'm going to do something here, and you can do it on your calculators too. Just so that I can see things a little bit better, I'm going to just hide those. So now I only see the blue one. Okay, so this is what I'm looking at, this blue one. On this curve right here, if you take a look at it, that's a possible inflection point, right? Because that's when the second derivative equals 0. So let's write that down. F double prime of x equals 0 or undefined at x equals negative, oops, I lost that point. Let's do that again. At x equals negative 1.2857. And then I have another one here where I have an asymptote at 0, and that's undefined as well. So those are my critical points. If I follow it along here, it won't cross that axis. It won't be 0 on this graph. So those are my two critical points. And then I can see intervals of concavity. So it's below the axis here, so it's concave down up to this point, right? So concave down up to that point, then concave up because it's positive, concave up, it's positive on the other side. Okay, so if I do the second derivative here, I need to examine negative 1.2857 and 0. From this, I'm below the axis, I'm negative. Over here, once I hit that, I go above the axis, stay above the axis the whole time. So like this, like this. That tells me there is my inflection point right there. So let's write that up. Okay, so I'm going to move this back over here a little bit. And let's write that up. So concavity, so concave up from negative 1.2857 to 0, union 0 to infinity. Down would be from negative infinity to negative 1.2857. And I do have an inflection point at x equals negative 1.2857. And that verified that. So I was able to do all that without having to take a derivative by hand. Where does this come in handy? When you have equations that are pretty difficult to take derivatives of. All right, let me look at something here. I want to show you something. I'm just going to show you the original. And this right here, notice how this is concave down, and then it switches to concave up. So, and where does that happen? That happens at that negative 1.2857 point. And this one won't find it. This calculator, as good as it is, it won't find it. Okay, but it's right around there. That's where it switches that concavity. It's concave up. And here, this is all concave up as well. So nothing changes here after that asymptote. All right, so let's take a look at that next problem that we have. And right here it says, use your graphing calculator to generate the graph of this and discuss the relative extrema, all that good stuff. So that's what we're going to do. Let's go ahead and do that. First of all, let's go in and clear out what we have on all of these equations. And I'm going to put in this equation, ln x divided by x. And then we're going to graph it, and we get something that looks like this. Let me make sure I move it all over here so you can kind of see it. I'm going to make the window a little bit different just so that we can see everything, and there it is. Now look at this. This looks like it goes up. This function goes up right here, and it'll hit some sort of 0 right there, and then it looks like, oh, it hits a maximum right there, and then it's down. So this looks like it's concave down, right, up to this point right, well, somewhere in here, and then it hits this maximum, right, it hits that maximum, it's concave down, hits that maximum, and then it looks like it might be concave up again based on how this is moving. Let's see. Yep, it looks like it's concave up again. So we need to find all that info and see what we could do with it. All right, let me change this to get back over here so we can see it. So let's use our calculator to do all that. So I've graphed it. Now let's get the first derivative, because f prime of x, let's change my color here, f prime of x equals 0 or undefined will give me my critical points. And from that, I can get the relative extrema, all that good stuff. So let's go ahead and do that. So we're going to go back to y equals. I'm going to go into here. I'm going to hit math. I want the derivative of the initial function with respect to x, and I want to put y1 there, so I'll go vars, y vars. Again, yours is pretty much the same similar structure here as mine. But but the menus on the TI are just a little bit different. So you'll be able to find them, pause it, and you can go through kind of pretty much the same stuff that I'm doing, and you'll see that. So there I graph it. The pink one right there, that colored one, is the derivative graph. Let's see if it does cross. And then how do you know on your calculators? Well, you're going to try to find, that's where they intersect, and right there is a 0. You're going to have to find that 0. And again, the method you use, you're going to be using that second calculate method right here. As I showed you before, you'll hit the second button, you'll hit that, and then it's going to ask you, it's going to show you the graph. You're going to have to say the left bound, the right bound, and then it asks that guess. So you'll have to go through that menu structure for the left bound, right bound, guess to find that 0. Okay, so this f prime of x is 0 at this point. So f prime of x, there is no undefined points that looks like, so f prime of x equals 0 at x equals 2.71828. You should recognize that number. That's a E, right? But we won't work with E right now. We're just going to work with our decimals. Okay, so that's that. And we can put this on a derivative graph. This is 2.71828. And to the left of that 0, we are above the axes. So our slopes are positive, right? This is an f prime graph. To the right of it, we are negative. We are below it. So that means we have a relative maximum at x equals 2.71828. And if you wanted the exact point, you can plug it back into your calculator, and that comes out to be, if I follow the green graph, there's my maximum, 2.71828, comma, 0.36788. There is my relative maximum. My intervals of increasing are from negative infinity to 2.71828. My decreasing is going to be from 2.71828 to infinity. All right, so concavity, f double prime, set it equal to 0 or undefined, and we can get concavity here. So I'm going to go through the process again since I'm doing this whole problem on my calculator. I'm going to hide these two. That way I only see that, because when you start seeing multiple graphs, it kind of gets a little bit confusing. All right, so let's go ahead and put this in. I want math. I want to take the derivative with respect to x. Now I want the y2 equation. So vars, y vars, and I want the y2 equation, and then I want it at every x value. That's why I put an x there. And remember, if you have the old software, you will be doing it this way, just like that. You just put in the equation and you're just changing what this y1 is. All right, so let's go ahead and do that. Let's hit the graph button, and this is what we get. I'm going to slide this over just a little bit so we can see it a little bit better. I'll enlarge this, and right here is where I'm looking, and I am following this. I want to find where it's 0, so you do the process of left bound, right bound. My calculator will tell me where it is. If you're wondering what this calculator is, it's called Calc 83. So go to the App Store. I'm not doing a plug for this guy, but just go to the App Store, and it's called Calc 83. It looks like this. Where is it? It looks like that. It's called Calc 83. Okay, so back to what we got going on here. And let's see. Over here, we've got our maximum that occurs, okay, at that, but that's not what I'm looking for. I'm looking for a 0. And there's another maximum. I'm looking for a 0. Let's see where that, oh, there's the 0 that I'm looking for. Okay, so f double prime of x equals 0. It doesn't look like there's any undefined places based on the domain that I have. So it's 0, oops. Go back to the correct marker at x equals 4.4817, we'll say. Okay, so that's where that 0 occurs, 4.4817. And then to the left of it, it's below the axis. To the right of it, it's above the axis. So, yep, This is an inflection point right there. It changes concavity. I'm looking again if there's a maximum right there, but it doesn't appear to have any other zeros. Okay, so it's concave down from negative infinity to 4.4817, and up from 4.4817 to infinity. So those are my intervals of concavity, and I have an inflection point at 4.4817, and I would have to plug it back into the original equation to get the y value. And let's go back to the original equation. Let's go ahead and I'm going to just look at this one graph over here. I can go on this one. It won't do the second value feature like yours, so I'm going to go ahead and skip that right now, finding that point for you guys. Okay, so it's somewhere right here, 4.4817. So somewhere around there, you would have to plug it in again to the original to get the x value. And I don't know if this calculator does it. It might, but we're going to skip that right now. All right, and if you look at the original, you could tell that yes, this is where you do have that inflection point happening, where you're changing concavity from concave down to concave up. And then, yep, you do have that maximum that occurred right there that we had found at 2.71828. All right, so that's how we do that. As far as asymptotes on this one, there was an asymptote at x equals 0 on the original equation. We found the inflection points, we found relative extrema, end behavior. As x goes to infinity, obviously it'll go to infinity. As x goes to negative, well, in this case, as x goes to 0, it's going to go to negative infinity. That would be the end behavior on that. All right, so hopefully you can do these on the calculator. If we'll do a couple more examples in class where I'll have you do these on the calculator. And the reason why you need to do it is because they're going to give you some things on the AP test that are very difficult to take derivatives of. So you're going to have to use your calculator to get that derivative to find any intervals where it's increasing and decreasing, because if you just plug it in, you may not be able to tell right away all the relative extrema and all those points as far as concavity is concerned as well. All right, so thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.